Welcome back to another NeetCode slash LeetCode grind video. Um, Again, I slept after lunch. That's why I'm groggy, but that doesn't mean we won't be doing our LeetCode slash LeetCode video grind session. I guess the first thing we'll do is we'll practice some of the questions that we did yesterday. One of them being a sliding window, which was the best time to buy and sell stocks. Right. So we'll try to solve this one more time, see how we did it, and yeah, I guess that's pretty much it. Yeah, let's go. You're given an integer array prices where prices I is the price of need code. Price of need coin on I there. You may choose a single day to buy one need coin and choose a different sell it. Um, yeah, so essentially what we could do is which is something like max profit is equal to 0. And the way we think about this is very simple. We first of all, let's say we just take on these stock prices. So if you make a graph about it, like if you see how it looks from a graph perspective, we have 10 over here, right? We have 1 over here. We'll have 5 over here. We'll have 6 over here. We will have 7 over here, and we'll have 1 over here, right? And if you look at the graph of how this is made, right? Um, so the very first thing is let's keep two pointers. So we'll have a left pointer and we will have a right pointer. Left pointer will be the day we buy some stock, and right pointer will be the day we sell that respective stock. Now the saying that goes in the stock market is buy low, sell high. So by that standard, what we want is our for order for a thing, we would want our R to be greater than prices L, right? In order to make a profit, right? Because we need to sell higher than what we buy. So let's say we have two pointers starting out right now over here, right? Now, if I compare them and I see, well, R is this is the opposite, right? Your L is greater than R. What that suggests to us is key. Why do we buy on 10 when I could just buy on 1, right? This is pretty much loss, so it's not even making any profit, right? So then what I will do is, because I see that there's a lesser price to buy the stock at, I will just move my left pointer and move my right pointer over here. So I'll move my left pointer to where R was, and then increment my right pointer to point to the next day. Now we see that you're making a profit because you're buying at $1 and selling at $5. So we make a profit of 4. So we'll update this in some max profit variable, right? And now we have 6 R. Now R uh, so again, as we see that our R is still less, our R, so again we are still buying we are still buying less than what we are selling, so we'll push our R over here, right? We'll calculate the profit again, and that's it. Then we come over here to R, and we calculate our profit again, and then we come over here, and there's not any profit. We'll come push our R over here, but that will be outside of the list. So how do we do this? So the very first thing we'll do, we will have a left pointer, will point at this element, then we'll have a right pointer that points to the very next element, that is 1. Now while L is less than R and R is less than length of prices, because our left will always be before R. The reason why is left shows our buy date, and as we know, we can't travel back in time, right? So that's why that we have those two conditions. I saw NeetCode do this without this. You can do that as well. So let's go. So if we have prices L, right? If our prices L is greater than our prices R, right? So if this price is more, we would want our L become R and R plus 1, elif prices L and prices R is more. So we can say max profit is equal to max profit prices R, and we know that this, right, and this is our good edge case where they both are equal. I mean, to be honest, if they're both equal, doesn't really matter what we do with them. We can pretty much say over here less than equal to, but let's just say if they are both equal, let us say that we just increment R itself, um, and then we return max profit, right? So let's see if this run. Okay, time limit exceeded. Okay. You see, this is the issue we had. So once we calculate the profit, right, we would just want to then just do R plus 1. And the funny thing is we're doing R plus 1 in all of them, so we could most likely just take it away, but I won't do it. I mean, to be honest, you could just do something like over here as well, because we're doing R plus 1 in each one of them, but no worries. And this should pass the test case. And if I submit this, this will also pass. And yeah, okay, great. That works. You could, like, we could do something like if it's greater than and equal to. So another way of solving this, we did something like greater than and equal to, and we did this as else statement, and remove that. Okay, this is and also one more thing we can do is we can do remove this, right? And now if I run the test case, this will again pass because we're doing the same thing roughly, right? So it works great. So that was the question we practiced yesterday. One more question we did was the reorder list question, which I was able to solve by myself, which is very interesting. The way I solved this was the way we were able to solve this question is we were initially we just I think I had this on top. Yeah, so we pretty much put this entire list into an array, so to speak. And so we have all nodes and we have quantities equal to it. The first thing is we just kept on um, in the list, right? So we just added them all in the list. We said our left node is, well, what is at the left side, and our right node is what are the -1. We do ln this, and right, and we do ln. I think I don't need that, right? Okay, I was like, why do I need that extra statement over there? Yeah, that is not needed, right? Um, why doesn't it show that I completed it? Wait a minute, just wait a minute. I think I've added some extra lines for no reason. This is not needed. I think I was practicing, like, I was like, how can I make this run? So yeah, that's not needed over there. And we can run this. This will pass, right? And I can submit this. Oh, so this is O of n. This is O of n time complexity because this is just gonna come closer and closer. The one sad thing is it's O of n space complexity as well. So right, so essentially what this was the algorithm. So very first thing is we have a left pointer, we have a right pointer. We connect our left node to the rightmost while also storing the leftmost that will come up to. Like, let me just show you the code. So we connect our list next to all nodes ln. So this is our lnx that we'll keep for at the moment. Then we'll do all nodes ln dot next is equal to all nodes rn. And what this means is, okay, that's pretty much rn, and then we do ln plus 1. Now it's pretty much it's um do I need this? actually don't need this because it's anyways gonna increment, right? So I actually don't need this. Yeah, well, that's funny because I don't need this because we don't have to store it because we know list में ही है, so we don't actually have to store it. Yeah, that's the thing. I was like, wait a minute, why did I need to do that? Same, do I need to do this? I don't need to do that. Yeah, okay, that's much better. Yeah, I was like, do I really need to do that? Because it's in the list, right? It's not like I have to save it up. It's in the list, and the moment they kind of like become greater than or equal to, it'll be at one moment. I just do that all nodes are in that X. Essentially, like, simple as that. Just do that. Right. What the hell? How did my runtime been so bad? And it's over here. My runtime is like, what the hell? Anyhow, so that is pretty much what we did. Obviously, there's a better solution that is in O of one space complexity. So yeah, let's. I tried doing this yesterday. Yeah, I'm sorry for the background noise that you guys might be hearing. Um, it is what it is. Let's continue. It's okay. Yep. Okay, so yeah, let's just go through this video one more time. And if I don't wanna do it, like I can do it tomorrow as well because I mean, doesn't really matter. But let's.
Hey everyone, welcome back and let's write some more NeetCode today. So today let's solve the problem reorder list. So we haven't done a linked list problem in a while, and this is a pretty common and interesting linked list problem. So we are given the head of a singly linked list, where we have the first value, the next value, etc., and we want to rearrange it into this, and this is going to go first and then this is going to go second. So obviously we're not merging them from the beginning. The second list is going to
Because the way he says it, right? The way he explains it is interesting, right, so to speak. But so the way he says we do this is, let's say we have 1, 2, 3, and 4. And so the way he does is, if you can like we need to, so the actual output is, well, 1, 4, 2, and 3. And so the way you want to do this is pretty much as we were like, so he says split this in half. So now we have two halves of a linked list pretty much, and then we connect this half with this half, and then we connect, so yeah, that makes sense, right? That's connected over there, and then we connect this half. It's pretty much as if this list was somewhere like this, like as if it was like 4, right? And so pretty much do this, and then we do this. Okay, it's a bit confusing right now, but sure, let's see.
be merged from the end. But if we're not putting this in an array, how exactly can we do that? Because we're going to have one pointer at the beginning of the first array. We're going to have one pointer at the
And this thing he says that's even more interesting in this question is, let's say if you were told that you have a linked list and I want you to find the middlemost value in this linked list without you able to count how many elements there are. So you should not know how many total elements there are in a linked list, like how many total nodes there are, but I want you to find me the middlemost node. And you'll be like, wow, that's like contradictory, right? How will you do that? The way you do that is very fascinating. You do something like a slow and fast pointer approach. And the moment I say that, we do think about that linked list cycle detection, which also used a slow and fast pointer, which was essentially like, if we start over here, our slow, so we have like bunch of this thing, our slow and fast pointer will be, our slow will be over here and our fast will be 2 steps ahead, right? Let's see how this goes like. So the way this thing goes is, we will have a slow pointer and we will have a fast pointer. So our fast pointer will be go ahead 2 times, so this will be our fast and this will be our slow, and then this will go 2 2 edge 1 2, so this is this, and this is this. So now it's pretty much over here, which is the halfway point. But now he says in a very weird way. He says this will go one, two, three, and then this will go over here. Like I don't know how does that work. Let me read.
End of the second, I think I said array, but what I meant is list. Obviously, we're going to have two lists. And so the first half of the list is going to be straightforward, right? We're going to take, this is going to be the node that goes at the beginning. Then we're going to take this pointer, shift it to the right. So that's pretty straightforward. But since we have a pointer at the end of the second list, and we take this node, we put it in the second position, right? We'll insert it somewhere in the middle over here. That's not impossible, right? We can do that pretty easily. But the problem becomes, okay, once we've inserted this node, then we want to move our pointer to this node, but the link is going the wrong way. The link is going in order, but we really want the link to be going in the opposite order, because when we traverse this second portion of the list, we're not going to be going from beginning to end. We're going to be going from end to beginning. So how can we do that without extra memory? Well, the easy way is, why not just reverse the links, right? For this entire second portion of the list, why don't we reverse every single link, and then we can do it pretty easily, right? There's no reason that we can't reverse the links. We're perfectly free to do that. So that's kind of what makes this problem a lot easier. There's going to be two phases to this algorithm mainly. We're going to take the second portion of the list, reverse it, and then we're going to take these two portions of the list and merge them together. This first, next this value, then this, right, etc., etc. The only other thing that I want to mention is when we're reversing the second half of the list, how do we know what is the second half? How do we know we've reached the second half, right? Starting from here is when we want to start reversing. How do we know once we get there? You could do it multiple ways. The easiest way is going to be a fast and slow pointer. So I'm going to have the slow pointer initially at the first and the fast pointer initially at the second node. We're going to be shifting the slow pointer by 1. We're going to be shifting the fast pointer by 2. And we're going to keep going until the fast pointer either reaches the end of the list or reaches the last value of the list. And once that is the case, we know that the slow pointer is going to be, if it's an even list, you can kind of run through it yourself and see that it does work. But if it's an even list, the slow pointer will be at the halfway point, pretty much, right? It'll be at the end of the first list, right? So then what we'll do is say, okay, slow dot next is going to be the beginning of the second half of the list. So that's what happens if we have an even number of nodes. What happens if we had a odd number of nodes? Let's see if the same thing works out for us. So if we had a slow pointer here and a fast pointer here, we'll shift the fast pointer by 2. It'll be over here. The slow pointer will be null over here. The question becomes, what in this case, and so it'll be at null over here. The slow points, what in this case, what's the second half of the list? Because obviously we have an odd number of nodes. Well, what we're going to say is this is going to be the second half of the list. Even though it's shorter than the first half of the list, it still works for us, because what the result in this case is going to be is basically, we have this second half of the list. This is the first half. We're going to take 1 at the beginning. We're going to take 5 in the next position. Then we're going to take 2 in the next position, right? We're just basically alternating. Then we're going to take 4 at the next position. And lastly, we're going to take 3 in the...
So we take, okay, yeah, so we take 1, 5, 2, 4. Okay, so 1, 5, 2, 4, and then 3. Yeah, I mean,
next position. So it does work out in this case. So you can see that, finding the middle of the list is something that can be done with 2 pointers, one fast and one slow. And in terms of actually taking these lists and merging them, it's pretty straightforward when you look at the picture. Actually coding it is a little bit tricky because we're going to have several different pointers, but just to give kind of the rough idea.
yeah, so I learned 3 concepts. First one is finding the middle point of a singly linked list, flipping a linked list, and rearranging a linked list. Interesting. Yeah.
Yeah.
Yeah, that's true though. Like, it can be done in OAuth 1, but then it creates such a amazing code. So the first thing we learned is how can we find the uh middlemost node of a linked list using two pointers. फ्लॉइड्स टोटस. अरे भाई ये कौन है भाई, ये फ्लॉइड टोटस बोथ हेड कौन है भाई.
We're obviously going to have a pointer here, which is going to be the beginning of the first. This pointer dot have a pointer here, which is we're going to call the second pointer, the beginning of the second list. Obviously, the link here is going to be going the other way. What we're going to do is we're going to take, okay, this pointer dot next, right? One dot next is, instead of being set to this node, we're going to break this link, set it equal to the second node, which is 5. And then, of course, 5 is pointing at this node 4. So instead of having it point at 4, we want it to be pointing at this node, which was the original next node for 1. So we're going to do that. 5 is going to point at the second node, and then we're going to shift our pointers. We're going to take this pointer, set it to 2, take this pointer, set it to 4. Now, obviously, notice how we broke the link in both spots. So how are we actually going to be able to shift the pointers if we broke the link already? Well, we're going to have to save that link before we actually break it. We're basically going to have a temporary variable, which is going to point at this node, and a temporary variable that's going to point at this node before we actually break these links. I think that'll make more sense when I actually code it up, but that's basically the idea. And obviously, these two pointers, we're going to keep shifting them until they basically meet each other. And actually, one last thing, notice how the first list, so when we actually cut this in half, once we actually have a first half and a second half of the list, for the last node in the first half of the list, we actually want it not to be pointing at 4, but since this is going to be the last node, we want this to be pointing at null. So that's one other thing that we're going to do. So obviously this is kind of about all the edge cases and making sure all of our... So now let's dive into the code. You can see we don't have to return anything. We just have to modify the list in place. So that's what we're going to do. And remember, the first thing we want to do is find the actual middle point of this list. So we're going to have 2 pointers, slow and fast. Slow is going to be at the head of the list, and fast is going to be head.next. We're going to keep going while fast is non-null and fast has not reached the end of the entire list. And as that's the case, we're going to basically shift each pointer. Slow is going to be shifted by 1. Fast is going to be shifted by 2. Okay, so that's great. So now we do have the beginning of the second half of the list. So we're going to have that second pointer. And remember, just like in the drawing picture, the beginning of the second half of the list is going to be the slow.next. So this is the second half of the list. But remember, now we actually have to reverse the second half of the list. Before I reverse it, I'm also going to say slow.next is going to be set to null, right? Because we're actually splitting this into 2 different lists. So that's how we're splitting it. Now we're actually going to be reversing that second half of the list. So we're going to say while second is non-null, we want to set it to the previous node. Initially, the previous node is just going to be null, so we can set that as well. I think I can actually do it on this line. Previous is also going to be set to null along with slow.next. So basically, each iteration of the loop, we're going to store a temporary variable for second.next. But before we actually shift our pointer, we're going to say second.next is going to be equal to previous, which is initially going to be null. And then, of course, we're going to update our pointer. So now previous is going to be equal to second, and second is going to be shifted to our temp, which is going to be the next node in the list. So with this loop, all we're doing is reversing the second portion of the list. Okay, so now is the part that the second half has been reversed. Now we're actually going to merge the 2 halves of the list. So the beginning of the second, right? We want to find that beginning of...
What's happening? Someone is talking, I guess. Anyhow.
the second, which is going to be the previous pointer actually, because remember, after this loop is done executing, second is going to be set to null, but previous is going to be set to whatever the last node that we looked at was, and whatever that last node is actually going to be the new head of the second half of the list.
Yep, he's right. So this pretty much this will be our previous pointing to while we go ahead. So yeah, that makes sense. So now if you think about it, we have 1, 2, and we have 4, and we have 3, and then this is pretty much a merger. Now if you have odd, you're kind of cooked, but if you don't, you can just do this, right? You do okay then. I mean, yeah, it indicates problems.
Similar to what we had in the drawing picture. So that's the second half. The first half is just going to start at the head, right? So what we can say is first is going to initially be the head, second is going to be whatever
Yeah.
happens to be in previous. And so once you have this, all we're doing now is actually going to be doing the merge for the two lists. And so we're going to keep going until one of the pointers is null. And we know that the second half of the list could be shorter than the first half. So we're just going to say, okay, while second is not null, let's continue to merge these lists. So first, what I'm going to say is, remember, we're going to be storing the next nodes in temporary variables because we know we're going to be breaking those links. So the first thing we're going to do is temp1 is going to be first.next because we're going to be modifying that link. And temp2 is going to be second.next because we're going to modify that link as well. So now that we saved those, what we can say is, okay, first.next now is going to be reassigned to second, and second.next is going to be assigned to temp1 because we're basically inserting the second node in between.
Just give me 2 minutes, guys. Just give me 2 minutes.
First and first.next, which is what temp1 is. So we're basically inserting it between those. So that's kind of the merging operation. Now we just need to shift our pointers so we can say, okay, first is now going to be set to temp1, second is going to be set to temp2, and we can actually put it on the same line just to make our code a little bit shorter. So that actually is the entire code. We don't have to actually return anything, like I said, and you can see that this is very efficient because we're not using any extra memory and we're doing this in linear time. We are iterating through the list, I think, twice, but that's not too bad. So I hope that this was helpful. If it was, please like and subscribe. It supports the channel a lot, and I'll hopefully see you pretty soon. Thanks for watching.
Okay, cool. So that was a video. So the first thing is, how do we find the middle pointer, right? This is worry about that, to be honest. Right. So he says, we'll have slow over here, and we will have fast over here, and the only reason we'll continue is either fast is not none or fast is not none, and fast dot next is not none. I mean, तो दूसरा statement तो रोक ही देगा ना, while fast and fast dot next, because oh, it has to go 1 2, it has to jump 2 places. So okay, what are we so let's say finding the middlemost node in the linked list. Right, so we have slow and fast, which is equal to head comma head dot next. And okay, so we say while fast to make sure key we're pointing at something normal, but this is a bit brave because he's assuming कि head null nahi hai, right? That's like one of those things कि head, this could be an issue if head is null, whichever they get. While fast and fast dot next, we will say slow is slow dot next, and fast is fast dot next, right? while fast and fast dot next, slow is equal to slow dot next, fast is equal to fast dot next. Okay. Now we are point. Now our slow pointer is pointing. So in this case, it will be pointing somewhere over here. So we would know that our second pointer would be slow dot next. Um, right, if I'm correct. Pointing to the middlemost node, the second becomes slow dot next, and actually before that, right, our second is slow dot next, and we say slow dot next is equal to. So what we do is actually we say, okay, this is our second, right, because this is slow, and then isko hum log, because ये connected as a, to be honest, like, अभी connected नहीं है, but yeah, this is essentially connected. But now we say this is our second, and then यहाँ पे हम लोग इसका link तोड़ देते हैं, right? Great. Um, when we say previous, we could also say something. Yeah, I mean, none. So while is second is, we'll say, um, I think I'll, yeah, so I'll say second dot next is equal to previous is equal to second, and second is equal to temp, right? So temp is equal to second dot next, second next is equal to previous is equal to second, and second is equal to temp. Makes sense. This reverses that, and right, and now we wanna start from previous. So our second will actually just be previous, because if you think about this, from if I'm over here, well, my temp is gonna be somewhere over here, right? And this will be pointing to its previous, which is none. um, and then the previous will be this, and then this will be actually this. Now it's not temp, so now this becomes our temp. This will become it, and this will essentially point to our previous while becoming previous itself, right? So now we have done this, that we have reversed the second half, and now we'll merge the two halves of the linked list. And actually, to the how does he like allocate it? First, okay, the first will still be head. Yes, that's correct. So first, first, second will be head and previous, right? Right. That doesn't really, right. That is fine. So yeah, essentially this is just finding out the middlemost element, reversing the chains, and then we are merging the two halves. So is either tak I can understand. Um, Finding the middlemost is kind of crazy. Okay, we've learned this. I think I don't really understand that. So while second is equal to temp is equal to second dot next. Um, okay, and in order to merge it, he says okay while second is there. Okay, let's see while second. Um, right, right. That's how we do it. This part is very understandable. Um, 27. It better be less than 27, else I'm gonna straight up. I'm not even using any memory over here. किस चीज़ का memory? इससे पहले तो मैं array use कर रहा था. Wha- Bro, it was 27. Now it's even more than the one than I used in array. Are you guys giving I can't believe, like, I can't believe, to be honest. Like, I can't sometimes. What is this solution? Head dot previous? Head dot previous? Where is bro? Bro, this ain't a property. What? Chat. I'm not even gonna look at resolution. He's returning something. Yeah, they're doing some black magic, obviously. Okay, so this makes sense. Merging arrays. Chat. Merging arrays. Okay, so let's look at the workflow, the way he's doing things. So we have one, we have two, three, and four. So the idea is he finds out the middlemost value. He cuts the link. So what he says, he makes two linked lists, and then he makes this list. So this is another list. He reverses this, so we get 4, 3, and none. And then he takes this, and he starts merging them. So we take 1, 4, 2, and 3. That's right. 1, 4, 2, 3. 1, 4, 2, 3. Yeah. That's what the entire flow is. I understood the flow. And so this is the first thing is finding out this is also मैं समझ गया क्या हो रहा है, because this is pretty much like this is reversing a linked list. I know this, we have done this question multiple times. Frankly, this is one of the first videos I did, right? Finding the this is a new approach. Again, this is also something that I've seen for the first time, merging two halves. um, so he only worries about second. कुछ दिया है क्या कंस्ट्रेंट पे हम लोग को? हाँ मतलब वन दिया है, ठीक है, that's why he's happy. हाँ ठीक है, तभी he's like not putting up checks over here, ठीक है. This seems very analogous to when we finding like cycles in a linked list, right? If I were to do linked list cycle, same here, close this. Yeah, so what we did over here was very simple. We had a slow pointer and we had a fast pointer. And what we did was we said, okay, well, slow and fast will be equal to head comma head dot next. I don't think we said head dot next. Length of the list to zero सकता है, right? So we did never said that. So we always said head, and we say while fast and fast dot next, right? So while fast, because we can't do head dot next, okay, because the length of the list can be zero and head can be null, and so you're saying a none type as an attribute next doesn't make sense. What we do is we do it fast and that. So while we do this, we then come and say why is the indentation all fucked up? Slow is equal to slow dot next. We do fast is equal to fast dot next. We do two times, right? And now if slow is equal to fast, we will just return true, else I'll just come here and return false. And this works in O of linear time, because if you see if we have a cycle, right? So initially slow and fast यहाँ पे है, we move slow over here and fast over here, and now pretty much it has to get up, it has to do 1 2 3, right? Because we have how many, we have 1 2 1 2 3 4, so we have 4, 4 minus 1, so 3, right? It has to go up to 3, but in every iteration fast comes by 1, but but slow comes by 1, fast goes by 2, so we get 3 minus 1, so this is 2. So every time it gets 1 by 1. This is pretty much O of n minus 1 में ये अपना it will match up, right? And if I actually run this to show that this is working, कहाँ गया? Oh my bad, sorry. And if I run this to show you, and again wrong answer, again no worries, what's the issue is, Okay, what's the issue over here? Is this are you guys running this solution? Because I'm confused. Which solution are you running this solution or what? Okay, let's see what the issue is. So we do slow is equal because we can't do next, right? वही तो है, we can't do next. Slow is it because of the indentation? Ah, come on. Because of the indentation, man. मैं क्या गलत कर रहा हूँ मैं? चलो guys, tea time. Talk to you guys later.